Today's show is an unprecedented event. I've never done anything quite like this, but I'm going to do an unboxing video. Actually, I'm going to have Andrew Jones with MoFi to do an unboxing video of his all-new speaker, the MoFi SourcePoint 10. And then the next episode of the show will be the actual review of the SourcePoint 10. But today we're going to do an unboxing video and also an extended interview with Andrew about how this design came together. It's a really interesting story. Stick with it and then stay tuned for the next show, which will be the actual review of the MoFi SourcePoint 10. How long have you been designing speakers?
40 years.
40 years, and it's taken 40 years to
even get to this point.
Thing?
Yes.
What is it called?
Imagine what I'll do in the next 40 years.
What is this box called?
The SourcePoint 10.
Wow. Who came up with that name?
Group effort.
A group effort?
Yeah.
This is a source point.
As opposed to point source. It's a play on words.
And it's 10, so it's a 10 inch.
And if it's a play on words of point source, what kind of 10 inch could it be?
Paper?
Concentric.
Oh, concentric. Sorry. I screwed that up. Okay. Concentric, of course. Wow. And it's in here. I'll tell you, I brought it up to the apartment. It's really heavy.
That's why we let you bring it up to the apartment.
Oh, thanks. But I'm old. But how heavy is it, first of all? I'm going to ask the
it's
important questions first.
It's about 46 pounds.
Yeah, that's a lot.
Yeah, it is a lot.
Yeah.
For my age.
For your age. Think of mine. All right, so let's crack open this puppy.
Okay.
This is my first and probably only unboxing video on the Audiophiliac channel. This is historic.
Except
and if you screw it up, we got another box over there.
It's my unboxing, apparently.
Oh, okay.
You're leaving it up to me to do it.
You haven't done this before? All right.
All right.
Be careful.
Knife, be careful.
Yeah, very short. I learned. Ooh. Does it have that new speaker smell?
I can't tell.
You almost did it
right.
Again. Wow. Oh, wait.
And it's double boxed.
Oh, yeah, I can see.
So we do that for shipping safety.
Yeah, okay, look, styrofoam. I've never seen that before.
Some rubber feet.
Rubber feet? We don't need those, though.
We don't need those.
No, this is exciting.
So we could actually either take this off or just tip it out.
You're the pro.
Down.
I mean, I've done a couple of these in my lifetime, but I'm deferring to you.
You can just hold open the flaps.
Sure.
Grill, separately
Very
packaged.
Large grill.
Large grill. Cloth bag.
Nice
Look
wood.
at that.
It's real wood, right?
It's a real wood veneer, yes. Very solid cabinet. 1 inch thick side walls. 1 inch thick side, 1 inch thick back and top and bottom.
And the front baffle?
2 inch.
2 inches? No wonder it's so freaking heavy.
So let's take it out.
Careful of the connectors. So pretty.
And there you have it.
Wow. Well, that's the back of it.
And there's
From the front.
So look at that.
So this driver is all new.
Absolutely new.
Absolutely.
Everything is pretty much custom tooled for this.
Now, up to this point, for TAD and ELAC and Pioneer, you've never designed a coaxial or point source that's that big?
Correct. I've never really worked with large drivers other than the bass drivers in the TAD.
Right.
And those were pure bass drivers. But I've never done a 10-inch bass mid-range.
Yeah.
And certainly never done a concentric speaker this big. And never done
what made you consider that, since you're breaking new ground? Why?
Partly rethinking the approaches I've taken in the past. in line with some of the things that we wanted to do with MoFi. They're giving me a clean sheet to work from, and the time to work on something.
Yeah, because this is just one model, right?
It's just one model. It's the first that's ready.
Right.
I'm in the process of working on others. I've got prototypes kind of underway right now. But I wanted to focus on getting this right, because this then informs for what the others should be like.
Right.
And I think give me a clean sheet, and the time gives me the possibility of thinking through what approach should I take, what have I done in the past, do I want to change that?
Right.
And
yeah, well, I mean, when you wake up every day and you think, I'm going to work on a project, I'm going to do driver, cabinet, crossover, how do you even think like beyond what you've already done, because you've done so much already? How do you top yourself?
It's partly when you go right back to the beginning and go, what do we want to achieve with this particular product?
Okay.
You've always got a price point in mind. You've got some basic targets, like how big can it be, how much bass capability. I've done lots of small speakers that have good bass, but they'll always be limited in bass output capability. There's only so much a 5-inch driver can do. Right. And I've done good demonstrations of pounding bass, get it in the right room with the right equipment, and you can be surprised.
Yeah.
But I can hear the limitations of what's going on there, but it's still fun. But one of the things we wanted with MoFi was good, impactful bass. And the other thought was this current, maybe it'll last, hopefully it'll last since I've just started to release this now, this idea of big woofers. We've gone in the last few years to smaller and smaller, narrower and narrower speakers. Right. Now, some people will say, but that makes imaging better. I would argue that that's not primarily or the only reason you get good imaging. I hope to prove this.
Yes, we're about to find out.
And that prevents you doing big woofers unless they're on the side. But there is this trend of going back to the old days.
Yeah.
JBL 100 reissue, KLH, and all these other models. And the mid-century modern vibe that went along with that.
Like the KLH.
Yeah. Right. Would it be interesting to look at that approach? And so I thought, well, big woofers, since I've never really investigated those other than one speaker, I'm always looking for the opportunity to think about different things. And what if I did that? And this is an opportunity to do that.
Yeah.
But when you start down that track, if it's not something I've done before, and everything's got to be new, you need time to work on it.
Right.
You can't just snap your fingers.
Right, because you're not just doing variations which you've already done.
Yes.
It's a whole new...
It's like doing a Mark 1, Mark 2, Mark 3. You kind of... I've always joked that when people said, what do you put in the Mark 2? Everything that I ran out of time to put into the Mark 1.
Right, I remember you saying that once, yeah.
So there's no precedent for me. And I've got to think from scratch. Right. So we've said it's got a big speaker, because of course if it's a 10-inch driver, the cabinet has to be big. So a big cabinet gives us possibilities that we were denied in a small cabinet. The old thing of bass extension, cabinet size, efficiency. Now I can have a bit of everything.
Yeah, yeah.
And especially with you going on about high efficiency speakers, I had that in the back of my mind.
Yes.
So we get to do a 10-inch, but in what configuration? Do I do a 3-way like I've traditionally done? Right. Obviously I'm a big fan of concentric drivers, and I've always said with concentric drivers, you don't want a 2-way. I've maybe done 1 or 2 small concentrics in the past, but moved away from that. I've always said I don't want the cone to move very far. What's the easiest way to stop it moving? Cut it off and have something else take over the bass.
Right.
So hence everything was a three-way. But a three-way gets very complicated. And especially with the crossover, when you're crossing over passively that low, if you're doing it all active, it's a different story. But you've still got the added cost of the extra driver. So what's the other way of reducing cone excursion? Big driver. Right? You got about 4 times the area. And since base level is swept volume, area times displacement, then you need only a quarter of the movement to get any particular base level. So for most of the time, except for the very lowest notes, you're going to have very little cone excursion, which solves that issue of me not wanting the cone to move much around the tweeter for a concentric driver.
That simple?
That's simple.
That easy? What are we
Wish it was.
waiting for all this here?
It wouldn't have taken
sorry.
So that's the basic premise. So now I hit the 2 points of I've kept my philosophies of concentric driver.
Oh, wait.
Mostly
What's the
intact.
difference between concentric and coaxial?
Oh, just interchangeable.
Oh, okay.
Coaxial means on the same axis. But those things where you have a tweeter poking out on a stalk in the middle, that's also a coax. So I tend to say concentric. It's not really sufficient explanation, but it's not using the word concentric.
Okay.
Which,
So for the most part, you can use them interchangeably.
yes. So when I start looking at it, 10-inch gives me a possibility of doing something I haven't done before. It gives me the possibility of going to a 2-way because I've reduced the cone motion, but I've got a lot of bass capability. So I'm doing something that I said I wasn't going to do, but I'm qualifying it. I still wouldn't want to do a 5-inch concentric just because I don't want that much cone motion.
As a full range driver.
As a 2-way concentric driver. So with a 10-inch, I've now solved those problems, but now introduced a new problem. How do I design a 10-inch woofer that goes up high enough in a 2-way system? They're not very common in audio circles. You know, the high efficiency crowd has solutions for that. And obviously in pro audio, they're very common. But I wouldn't class what is required in pro audio speakers to be the same as what's required in a home audio speaker. So I got to look into, my first part was, can I make a 10-inch operate high enough with the quality level I want?
And what is high enough?
I want it clean up to at least 3K.
Oh, really?
And above that, I want it, you're going to have some cone resonances there, but I want it well controlled. But I also want to move the crossover point as low as I can from the tweeter. So I'm about the same ratio away from the first cone modes as I would be with a smaller speaker. So I've got to look at what are the best cone materials to use, how to engineer the tweeter to go down low enough. And I've got something working for me there, which is the fact that the bigger the waveguide, which is what the cone becomes, the more loading it gives down to a much lower frequency.
Can I use the H word?
Horn.
Horn.
A horn is a subset of waveguides.
Okay.
So in our popular thinking, when we think of horns, we think of the waveguide part of it plus the compression driver.
Right.
We don't think of horns and
Right.
along with direct radiator drivers. So it's going to give me a lot of help at the bottom end of the tweeter. So as long as I can get the resonant frequency down low enough, I can pick up so much extra efficiency at the low end of the tweeter, which means much less input required at those frequencies, so much less thermal compression. It also means much less movement from the tweeter for a given sound pressure level. So I can trade that much less movement for the more movement you pick up as you push the tweeter down in frequency. So they kind of balance each other out. And so work on a tweeter, get the crossover down to 1.6K, that gives me more room to maneuver with the cone design of the woofer. The cone design is both material and shape. The profile has to be right to provide the correct wavefront expansion from the tweeter. So you get smooth response, or as smooth as you can, both on axis and off axis. But then that cone shape also has to perform double duty, because it's got to be the right shape to get the right characteristics out of the material that you're using for the woofer. What should that material be? Well, that's a big problem, because a lot of the exotic materials we use in smaller drivers. We don't so much use them in big drivers because in one sense they're wasted. Let's take beryllium for an example. My 6-inch beryllium driver from TAD, first breakup mode 9.5K. That's pretty good for a 6.5-inch driver. Now, what if I were to build a 10-inch beryllium woofer?
Sounds expensive.
Sounds ludicrously expensive. No one's yet, I don't even know if anyone's thought of attempting it, but it would be ridiculously expensive, very expensive to tool up to do. And for what end? Because in a bass driver, you're crossing over 100, 200 hertz, so you don't need a huge high frequency for that first breakup mode. It's always how many octaves is it above where you're going to be using that driver. So that would be a waste normally, except this one needs to go up to about 3K, let's say. Beyond that impossibility of beryllium, what other exotic cone materials are there? And when I looked through them all and looked at examples of them, none of them were really giving me that much advantage compared to paper. Right?
Go back
I
to paper.
started looking at a lot of the PA type drivers, the base mid type drivers, and looking where their breakup modes were. And a lot of them were not good because it didn't really matter too much. Some of them showed real promise. So I thought, no, this could be doable. Can I develop a new paper cone? Because none of the profiles that were out there were the duality of what I needed. So I got to tool up my own paper cones, start from scratch, play around, and particularly the combination of the size of voice coil I needed with the outer trim diameter of the cone.
How big is the voice coil?
It's 48 millimeters. Sorry to switch
sorry.
to metric. It's exactly 48 millimeters.
Okay.
So it's just under 2 inches. That didn't exist. So another reason why I had to tool up the cone. And then I have to go through a couple of iterations on shape and pulp mixture and these kind of things.
You're actually making the pulp, like putting things in a blender and
chewing the paper and spitting out and patting it down, that kind of thing.
I want to see that. Yeah, that's the next video.
So the other thing is the surround that I use.
Yeah.
Because as always I've said that if you have a tall surround, it's going to mess up the wavefront propagation.
Right.
So what I've got is a corrugated edge or concertina edge. There's lots of different, but the multi-roll surround, just like you see on pro drivers. But this is tooled specifically for this, made from neoprene. And then I had to play with the characteristics of that to give it the right match to the cone so I don't get too many issues. So everything for that was tooled. And started building samples, and it was looking really nice. So with a bit of fiddling and fudging, I got a performance that technically, measurement-wise, I wanted. What's it going to sound like? I don't know, because
come on.
I haven't listened to it yet. But I had to commit to at least paying to tool up all these things so I could build a driver.
Right.
And along with that is, since it's a concentric driver and the tweeter's going down the middle, I need magnet structures that allow me to do that.
Right.
And I have to use a neo structure, a neodymium magnet for the tweeter, because ferrite can't give me enough energy density to get down in the middle of even a 48
and you need
millimeter.
sensitivity.
And I need sensitivity. So, okay, let's do a neodymium magnet on the woofer as well. And what I was able to do is couple them together. Recognize that this is going to be built as two separate structures, but once they're together, they can couple together so that each helps the other. And that way, I'm getting more flux in the gap for the tweeter, more flux in the gap for the woofer. And also, they work in a way that it improves the linearity. You know, one of the problems of a driver is that if it's non-linear, which of course the premise is all drivers are non-linear.
Right, yeah, I was going to say.
If they are, how do we reduce that? What are the mechanisms that cause that? One of which is flux modulation. The magnets provide a fixed flux in the gap, and the current through the coil produces a magnetic field to react against that fixed flux and move the coil. Wonderful. Yeah. If by fixed flux we meant that it was fixed.
Right.
But because the coil's in that gap, it drives flux through the magnet and alters that fixed flux. So you get a modulation effect there. So I wanted to try and reduce that, reduce inductance modulation effects because they also cause intermodulation distortion. There's all these different mechanisms that happen. So I was able to come up with this array, and we're calling it twin drive. Ooh. Yeah. Helps that I'm a twin, so that's where this idea came from. Not my idea, but it works. So that meant I had to tool up all of that, and the sizes of Neo that I needed weren't off the shelf. So I have to have the Neo machined to the sizes I want. So all of this goes to a very intensive development process of designing every part of that. And then the tweeter is a soft dome tweeter, a kind of silk cloth mix. But it's 1.25 inches to get me some extra power handling and sensitivity, wide roll surround. So it's kind of old school in a lot of ways, that paper and silk, 10-inch, two-way, how can this be one of my speakers? Yeah. You know, I've often joked about going back to some of the earliest speakers I've ever worked on, you know, like my first KEF speaker. What would happen if I got that and just took some of those parts, but with what I know now, re-engineer it? This is almost along those lines. It's taking everything I've thought about through the years and not deliberately trying to go old school. Some of the decisions appear old school just because of that first concept, a 10-inch woofer. What am I going to do if I go to the big woofer solution? But that just drove all these other ideas as to, ooh, I could do that and I could do it, but that forces me to do this, so how do I make that work?
Let me ask you a question. So as you're doing this, in this story, in this timeline you're laying out, do you actually have any physical prototypes?
Yeah.
Oh, you do? Okay.
Littered.
How many?
Littered around.
How many to make a speaker like this of drivers?
I got about 10 different versions of the woofer around, lying around and playing with, because you know it's like I say, pulp mixture, what the surround material is made of, how thick is it, do I need to dope it, all these kind of decisions, and then magnets especially, and trying to play with how I put the copper in the gap, which helps with reduction of the distortion. Do I have enough clearance so it doesn't rub? And just practical things of trying to make sure there's sufficient clearance, especially with the concentric driver, because with the tweeter being on the top, the voice coil former has to be longer. So there's more possibility. A small angular rotation would cause a rub. So you got to make sure all of that is right for production. You know, you can't just build a prototype and go, we're done, you take care of the rest. I mean, I have to oversee all of that. And then
The cabinet.
Here we are. So in the cabinet, we've done all this work to optimize the wavefront from the tweeter. If we then put it on the front of a flat rectangular box, it's all going to diffract off those edges and cause problems, and especially with the concentric, because it's not like you can readily mount the tweeter off center.
Mm-hmm.
So only by accident if you built it wrong.
Right.
So
I've done that.
now, how do I minimize some of the diffraction issues? So I was thinking back to when I first developed the TAD speakers, the original model one that had the cast head on top.
Yeah,
and
it's funny. I was thinking about that.
Yeah.
That curve on the top.
Yeah.
Right. Yeah.
So it curves in 3 dimensions. So it curves. It's a complex shape curving backwards. So when you do that, by the time you get to the edges, even though the edges were rounded, they would still have some effect. But the effect is minimized. You don't get these sharp discontinuities and interference effects. So that's if you use a continuous curvature. And even with something like the KEF LS50, that uses the same principle.
Right.
Curve it backwards in 3 dimensions and you get a reduction in diffraction effects. So the other approach is have lots of edges that are non-parallel or angles with respect to the driver, and then cut facets so that you've got different areas spreading backwards. So that's what we've done.
You tilt it back maybe now.
So we have a close edge. That's fine because that's just where it emerges. But you got this shape of the flat part of the baffle. Then these facets, kind of different angles and areas, and that helps reduce that diffraction. When we're looking at now, this idea has been used by lots of speakers. Avalon is a good example. But when we looked at it and gave it to the industrial design, we said, we like faceted, and these are some of the constraints we have. Can you do something with that? I don't want it to just look like the other speakers. But since we've also said we're going for this mid-century modern look, and in those days you had the picture frame around the edge of the speaker. So the designer put this picture frame around, and when I saw those renderings, that's it. Now I was afraid because I've done everything to minimize diffraction, but then we put a diffracting lip on the edge. But because it's set back, it doesn't have too much impact. It has a little impact, but I checked it. I modelled that up out of foam core board. I got a flat projection of this surface and then got my knife out and cut out the thing and built it up. And then I experimented with this edge and proved to myself that it was going to work okay. So then that gives us the shape of the cabinet. And if it, not easy to see, but it's straight there and then tapers in a little towards the back, just to give it a bit more form. Twin vents on the back. And I use twin ones because if I use a single one, whenever you get a standing wave inside the cabinet at some frequency, there'll be a strong driving pressure from the standing wave. And if that's by the port, you as you look at the output from the port, instead of nicely falling off, it goes in, you can see resonances and anti-resonances. If you use 2 vents spaced the right distance for that particular mode, they drive that mode in opposite phase. So in the far field, energy-wise, they tend to cancel out. And it's an easy way to get the total area I need to get low.
So here's the big question. So you get this all together, right? And you get a complete prototype speaker, and you listen to it. What happens? Is it like, oh no, I got to do so much more work, or it's perfect?
I wouldn't be here if my reaction is, crap, I've got to start again.
Well, not start again. Was it what you dreamed it to be?
It was, my thought was, what will it sound like if I do these kind of what seem to be old technologies and put them all together, but with more modern thinking. I have to say, I mean, it gave me the bass slam that I wanted and this tightness. One of the things that reducing distortion, or particularly modulation distortion, does is gives you this cleanliness that no matter how loud you play, you just think,
you don't get that
you can
sense
turn it up
of
more.
Yeah.
You don't feel your ear or the speaker is giving up. And when you've got that, when we talk about, for example, bass slam, you get that from having good enough low bass capability and no compression from the drive unit, so it can just keep going. But the biggest slam is from the biggest sound volume. You don't hear slam, gut thumping slam when you're playing at low levels.
Right.
So you turn it up and up, but often it's the rest of the range that sets the limit on how loud you can hear that.
Okay.
So if there doesn't seem to be that limit, you can have the party level bass. And I feel that's fulfilled the object that a 10-inch driver ought to give you, but the dual benefit being a concentric, it's got this imaging. Now I'm of course saying, but I feel it's got the imaging that you'd expect from the concentric driver, and especially when you think of the size of the driver, so it's controlling the off-axis response over a wider frequency range than it does typically with a small driver. But it's got this clarity, this hear-through, that's got me excited. Because one of the other things, when you think about cone resonances, is that suppose there's a resonance at 4K. If you put a crossover in at 2K and it's high enough slope, you think, I'm not even exciting that resonance, I'm done. That would be great if it was a linear system, but it's not. In a linear system, it matters whether you're filtering at the input of it or the output of it. We're filtering at the input. So suppose it's a 2K crossover. I put in 1 kilohertz. Let's say, for ease of numbers, the breakup mode is at 3K and it's 15, 20 dB high. The 1 kilohertz goes into the motor structure, creates the third harmonic distortion, which is at 3K, hasn't been filtered off. And now that hits that 20 dB peak, and now the third harmonic distortion appears awful for that 1 kilohertz tone. And then you factor in intermodulation distortion, things like that. So one of the keys to getting good sound from a cone that at some point has resonances is not give it the energy to have those resonances. And the key to that is a low distortion motor system. So I think I've packed a lot into this. And we'll see.
So you get it, you listen to it, it's where it's supposed to be, but you're now the only person that's actually heard it, right?
Yes.
So what is that like when you go, okay, now I'm ready to play it for other people at MoFi, and so how does that, you're like going, hey, I hope they like what I'm doing here, right?
Well, I could say that the reason they wanted me to work with them is they like what I do.
Right.
So if they're already predisposed to what I've done in the past, and I really like what I've done now.
But this is such a clean break from what you've done in the past.
And when I set that speaker up to listen, I was kind of just, instead of work, I can, technically I'm working because I'm supposed to be listening to it, but you don't feel like you're working because you just sit in front of the speakers in that room that I feel I've got a really nice sound from. And just, the old adage, what will this sound like on this? And going through all your recordings going, oh, that's what it sounds like. And I've just been enjoying myself so much. It's a fantastic feeling.
Bingo.
Yeah.
That's awesome. I think we did it. I think we're good. Now I got to listen to this thing.
Now you got to listen to it.
Yeah. I'm nervous. Not really. Yeah. Anyway, guys. My name is Steve Guttenberg. My guest today is most obviously the rock star himself, Andrew Jones from MoFi, and I love my job. This is the best part. So thank you, Andrew.
All right, cheers. Steve.
Thank you, John.